Hey guys, welcome back. Today in day 3, part 4, which is the last part for string and characters, we will go over three topics: substrings, comparing strings, and Unicode representation of strings. Yeah, for first of all, we need to create a playground. So I'll go here and I create a new playground. I'll go and choose blank. And then I'll go to my documents and I have a directory for learning iOS. Here I have all of my playground. I found this one, part 3, so this will be part 4. Yeah, so let's create it. Okay, so this will be, yeah, our substring, starting with substrings. So let's go here and we need to import UI kit because we're gonna work with user interface kit. And yeah, so let's start our video. So substring, when you get a substring from a string, the result is an instance of substring, not another string. So what that means? So it means that substring is in Swift have most of the same methods as a string, which meaning you can work with substrings the same way you work with strings. However, unlike strings, you use substrings for only a short amount of time while performing action on a string. So short amount of the time. When you are ready to store the result for a longer time, you convert the substring to an instance of a string. Here we go. This is our example. I'll take it to our playground and here we're gonna check it out. So here you will see this is hello world and this is an index we made. So this index gets the first location of that from comma in my string, and if cannot find it, so here we say default for if it was no nil, gonna be creating dot end string, gonna be end of the location. So I can make a range now from start to index, and so this beginning will be hello as you see here, but this is an instance of this, and if I want to convert it for long-term use, I need to make a string with initializer of a string and give this as an input, and then this will be long-term string. So and value copy so value type, and don't be dependent on the main string. Okay, so you may say why, and yeah, this is because of the approach of the approach of Swift for this is that a string take an storage. Okay, substring use same storage for keeping the memory, keeping that value. Okay, and if we want and we use initializer, then it will convert it to another string for long term in another spot in storage. Okay, and yeah, now just here, just remind us that both string and substring conform to the string protocol. So this protocol, if you like it, then you can go and see what is a string protocol. It's a type that can represent a string as a collection of characters. Okay, so both can be represent a collection of characters, and these are our properties and initializers and methods available for this we can use. And okay, so let's go for next topic, comparing string. So we have three way for comparing string. First is a string and character equality, which we use double equal operator or not an equal operators. Also we have a prefix equality and suffix equality for comparing strings. So here is comparing of a string. Let's make it here, and string and character equality. Okay, and let me copy this here and check this out. Here we go. So we have these two string, and with this double equal operator we're gonna compare them, and as you see here they are compared, so we will see this print in console. Okay, and so when two string value are considered equal if their extended grapheme cluster, you know that, what is it? In part 3 we went over that, are canonically equivalent. So when they're going to be a canonically equivalent, so extended graphic cluster are canonically equivalent if two parameters, if they have the same linguistic, and if they have linguistic meaning and same appearance. So even if they are composed from different Unicode scholar, doesn't matter. If they have the same linguistic meaning and appearance, then they're okay. So here you will see example that's a small letter E with equate. This is equal with a small letter E without equate, but followed with combining equate accents. So both will be this character, and they will be equal. Let's check it out. Here you go. Yes, they are equal. Okay. And we have other option that you will see that if they are not linguistic equal, meaning the same, then they are not equal. So Latin capital letter A used in English a lot. Okay, and we have it's not equal with Cyrillic capital letter A, which is using in Russian. So the characters are visually similar, but they don't have the same linguistic meaning. Here we go. So I believe now you get it. That's these are not equal. They are not equivalent because they are not the same linguistic meaning. Okay. So this is how the two characters will be equal in Swift. A string, also you need to know, a string and character combining, comparison in Swift are not local sensitive. So you may say, what's local sensitive? For make it more clear for yourself, you can Google it and get it out. That's what that means. So here I found that as an operation that required a local to perform its task is called local sensitive. If you want to know more, you can go through this website and learn for all topics about that. There's no time for us to going over that. And prefix and suffix equality is another title. We will go over it today, actually in this part. To check, we have two methods, has suffix and has prefix, that check that if the string is in our main string. So it's exactly go by same comparison for linguistic meaning and same appearance, word by word. And here is our let's I make this array of strings here, and then here for has prefix, I'm gonna check it out to see if there is act 1 in this, how many of that we have, and you will see there are 5 act 1. So you want, yeah, if you count it, you will see yes, there are 5. So it's and how it's work, it's gonna check character by character. Let's see what exactly example. Character string, particular string per character by character if they are linguistic, and you know, other part linguistic, and per appearance all equal. So this is for perfect, so we use has perfects. Also we have another function which means has suffix. So start to check to see if there are suffix equal with this, and here if you run this you will see how it's worked. That's count 6 meaning seen and 2. So here for us count this in compare one by one with this and with this inside this array of strings, and find out that if they are in there or not. So has prefix and has suffix methods perform a character by character canonically equivalent comparison between the extended grapheme cluster in each string as described in string and character equality in actually I believe section 3. Okay, so Unicode representation of a string is the last topic for actually this part and today totally, and I'll go over that, and it's I just briefly go over that to get you. So when we want to save our Unicode string in a text file, we have three format to save it. We have UTF-8, UTF-16, and UTF-32 or Unicode Scholar. And let's go one by one. So UTF-8, it's gonna be like this. It's gonna get 9 spot and use any spot maximum UTF-8, and how we can access is gonna be a string name and dot UTF-8, and here you will see will be our usage. And the other one, UTF-16. Yeah, because dog string is not declared. Yes, I need to make it. So yeah, I forgot to tell you that. Yes, here you go. We can declare dog string, and then when we run it, we will see in output this. And so for UTF-6, you will see that exactly gonna be these spots and 9 spots for representation, and you will see you can go through this picture and find out which letter gonna be in which format saved there. For UTF-16 we have this, and which you will get 5 spot, and for Unicode Scholar representation and here you see we use the string and dot 16 in a one for loop, and one by one we're gonna print it out, and we do it for Unicode Scholar. It will get 4 spots, and here you go. You will see the result. And here, yeah, for Unicode Scholar, yeah, here you go. And here you will see it's gonna get 5 times, and this will be how format will be. Yeah, that's it for today. This is all about a string and characters we can learn in Swift. In this 4 video Okay, that's it for today. I hope you like the video. If you like it, please make sure to give it thumbs up, and also don't forget to be subscribed for more video all coming every day. And if you have any question, please ask in comment below. I will be more than happy to help you and answer your questions. And I wish the best for you. Have a good one. Bye bye.